everyone. So let's go ahead and continue along with section A9, talking about interval notation. Now we're just going to go through a few examples going from interval notation to inequalities to the graph and kind of moving between those based on what we were given. So in these first set of examples, we want to express the given graph in interval notation and as an inequality. Whoops. So let's take a look at a couple of these. First one, we're given the graph that looks like the following. So we're going to have the numbers -1 and 3. And on the left side, we're going to have a parenthesis at -1, a bracket at 3, and then shaded in between. So this is our graph. This is given to us. And so what we want to do is we want to write the interval notation and also write this as an inequality. So let's go ahead and do interval notation first. This one's usually really nice to come up with if we're given the graph, because it pretty much follows along with what we have right here. So with interval notation and same with the graphs, you always want to go from least to greatest. So starting on the furthest left we go is -1. And we have a parenthesis at -1. So we're going to do the exact same thing for our interval notation. We're going to start at -1 with a parenthesis, comma, the furthest right that we go is 3 with a bracket. So again, follow directly along from the graph that we're given. So for the inequality, this one's pretty nice. We're going to be between two numbers. So when you have two distinct numbers here and not positive or negative infinity, what I like to do is set up the x in the middle and put our two numbers on either side. Always the smallest number on the left, largest number on the right. So let's go ahead and put -1 on the left, 3 on the right, leaving a little bit of space for our actual inequality symbols. Now, to figure out if it's going to be a less than or equal to, we're going to look at our parentheses and brackets. Because it's a parenthesis at -1, we're going to have a less than. Because there's a bracket at 3, we're going to have a less than or equal to. So we have x right in between -1 and 3, with the less than for -1 and a less than or equal to for 3. So this is just saying that any x value between -1 and 3 is part of our solution. We can include 3, but we can't include -1. So let's go ahead and try one of these where we have a graph that isn't between two set numbers. So we're going to do one where we have an infinity or negative infinity. So we're given the graph where we have 5 in the middle and then a parenthesis facing the left and shading all the way down to the left-hand side of the graph. And again, we're going to look for interval notation and the inequality. So for the interval notation, again, still getting it directly from the graph, you want to go from your furthest left to the furthest right. So the furthest left that we go on the graph is all the way down to the very left end of the number line. which is negative infinity. So that's where our interval is going to start. We're going to start at negative infinity. We always put parentheses there because, again, we can't actually equal a negative infinity or positive infinity. And then comma, the furthest right that we go is 5 with a parenthesis. So our interval is from negative infinity to 5 with parentheses on both of those. For the inequality, we're not going to have x between two numbers. It's either going to be x is greater than something or x is less than something. And if we look at our graph, we can see that x is less than 5. So it's any number smaller than 5. If it were shading to the right, it would be x is greater than 5. But for this one, because we have a parenthesis of 5 and it's everything less than 5, we're going to have x is less than 5. So again, when you have those infinities, it's just x and the number, and then either greater than or less than. Let's go ahead and take a look at some examples where we're given a different piece of information. So these ones we were given graphs for both. Now, in our next set, we're going to be given the inequality. So we're told to express the inequality as an interval, then graph. So number one here, we're given the inequality 6 is less than or equal to x is less than or equal to 10. And so we can do whichever we want first. In MyMathLab, it's going to have you do the inequality and then graph it. But if you really like graphing when you're, it's going to have you do the interval and then graph it. If you really like graphing first and then finding the interval, you can always just do that separately and then just do it on a separate sheet of paper and then put your answers in afterwards. Sometimes it just makes a little bit more sense to do the graph first and then find the interval. Whichever one you like more, I would just kind of stick to that. All right, so for the interval or the interval notation, we're going to take a look at our two numbers. So we're given 6 and 10, and we want to pay attention to the symbols that are next to them. So they're both less than or equal to, which means that we're going to be using brackets on both of them. So we're going to have bracket 6, comma 10, so just our two numbers, and brackets around both of those. And then taking this interval and going to the graph, we're going to put our two numbers on there, so 6 and 10. And the graph is going to follow directly from the interval notation. We're going to bring down those brackets on both the 6 and the 10, still facing inwards, and then shade everything in between. So this one's kind of the nicer case where you have two distinct numbers. But what if we're given something where we're going to have to use an infinity? So let's say we're given x is greater than or equal to 3. So we're going to find the interval notation and the graph. And for this one, what I'm actually going to do is graph it first. It's a little bit easier to find the interval after you graph. So this inequality is saying we want all numbers that are bigger than or equal to 3. So I'm going to put 3 in the middle, and then all numbers that are bigger than 3 are to the right of 3. Since we can actually equal 3, it's greater than or equal to, we're going to use a bracket facing the direction that we shaded, so facing to the right. So the graph is done, and now the interval is going to come straight from the graph. we're going to go from furthest left to furthest right. So the furthest left that we go is 3, and there's a bracket there, comma, the furthest right that we go is all the way to the end of the number line on the right. That is a positive infinity. So we're going to have 3 to infinity with a parenthesis there, always. Even if you have a bracket on the other side, you'll always have a parenthesis next to positive or negative infinity. So that's the case where we're going from an inequality to the interval and graph. Now our last case is going to be if we're given the interval notation and we're going to go to inequality and graph. So our last set of examples, we're told to write the given interval as an inequality and then graph. So number 1 here, we're given the inequality from 3 to 7 with a bracket on the 3, parenthesis on the 7. So we want to find our inequality and graph. And this one doesn't matter a whole lot which one you do first. So I'll go ahead and just do the inequality first. So since we have 2 distinct numbers, we're going to have that case again where x is sandwiched in between those 2 numbers. So I'm going to put x in the middle, positive 3 on the left, positive 7 on the right, leaving some space for those inequality signs. Now all we have to do is figure out which one goes where. So since we have a bracket next to the 3, this means we want to use a less than or equal to. So I'll put that between the 3 and the x. There's a parenthesis at 7, so we're going to use a less than symbol there. That's our inequality done. Whoops. Now we can go ahead and graph it. And again, I'm going to use the interval to graph it. We could always reference the inequality as well. But we're going to have our 2 numbers on the number line. So 3 on the left, 7 on the right. And using the exact same symbols we have in the interval notation. So bracket at 3, parenthesis at 7. Let's go ahead and put those on there. And they're both facing inwards because we're going to shade in between. So this is saying any number between 3 and 7, including 3, but not 7, is a solution to whatever this problem was. So let's go ahead and try one more of these and we'll call it good for this section. So the last one here, we're given the interval from negative infinity to negative 2, parentheses at both of those. And we're looking for the there's a notification that came up. Let me get rid of that. We're looking for the inequality and graph. And again, doesn't really matter which one you do first, whichever one kind of makes more sense to you. So for this interval, we're going from negative infinity to negative 2. I'm actually going to start with the graph first because I like graphing from the interval first, and then makes the inequality make a little bit more sense with these infinities. So our only distinct number here is negative 2. The other is a negative infinity. So I'll put negative 2 in the middle. And we want all numbers from negative infinity, which I know is the furthest left on the number line, up to negative 2, which means I can shade everything from negative infinity to negative 2. And then there's a parenthesis at negative 2. So we're going to bring that over and put that on the graph as well. So now looking at the graph and going to inequality or our inequality form, we want all of the numbers that are less than 2. Strictly less than because we don't have a bracket. So we're going to have x is less than 2. It's not sandwiched in between two numbers this time because one of our endpoints is negative infinity. So we just have x is less than 2, and we're not going to put that negative infinity on there. All right, so that's pretty much everything you're going to see in section A9. So you should be set to do the homework if you want to get started on that. If you're watching this before Monday, then the homework assignments are not open yet, but they will open on Monday. So next time we're going to start factoring, which again, like I mentioned before, super important. So we'll do that on Tuesday. And if you have any questions on this lecture, come prepared with them on Tuesday so that I can go over them.